Hi, today we're going over section 2.3, multiplying and dividing radical expressions. Recall for variables, if we had two binomials, like x plus 1 times x plus 3, we would use something known as FOIL to multiply them out. The F stood for first, which meant we multiplied our x by x, our first term by our first term, so that would be x squared. So FOIL was first. O stands for outside, so our two outside terms. So we have x times 3 gives us 3x. I was inside. So that's our two inside terms. So 1 times x is x. And then L stood for last. So we multiplied the two last terms together. So 1 times 3. So plus 3. We then combine like terms. So we have x squared plus 3x plus x is 4x plus 3. Now, when we deal with radicals, we'll do it in a very similar way. So we'll still be using the FOIL principles. Now, when we multiply, we'll multiply our coefficients together, and then we'll multiply what's inside our radicals together. So we can multiply radicals in a similar way, like I was just mentioning. When multiplying radicals, the numbers in the radicals are multiplied together and stay inside the radical. Coefficients get multiplied together and stay as coefficients. And when adding or subtracting our radicals after we've multiplied them out, we can only add or subtract them if what's inside the radical is the same. Okay, so for example, expand and simplify. So we'll FOIL this out. So we have our first, so that would be this times this. So like I mentioned on the previous page, when multiplying radicals, the coefficients get multiplied together. So we have 4 times 4 would be 16. And then what's inside the radical gets multiplied together. So root 2 times root 2 would be root 4. Next, we have outside. So 4 root 2 times negative 2 root 3. So 4 times negative 2 would give us negative 8. Root 2 times root 3 gives us root 6. Next, we have our inside term. So 2 root 3 times 4 root 2. So we have 2 times 4. So that gives us plus 8. And then root 3 times root 2 gives us root 6. And then we have last. So 2 root 3 times negative 2 root 3. So 2 times negative 2 is negative 4. Root 3 times root 3 is root 9. We'll then go through and simplify this. 16 root 4 is the same as 16 times 2. Now we've got negative 8 root 6, positive 8 root 6, so these cancel out. So you'll notice that these canceled out. That's because of something that happened up here. So when the factors are the same, but with an opposite sign, because you notice both have 4 root 2, both have 2 root 3, but one's plus between them, one's a minus. So if when the factors are the same, but have an opposite middle sign, they are what is known as conjugates of each other. Which produces a difference of squares and makes our middle terms cancel out. Now, like I said, that only happens if everything's the same other than our middle terms. And then, so if that deals with that part of it, then we've got -4 times square root of 9 is 3. So 16 times 2 is 32. Minus 4 times 3, so minus 12. 32 minus 12 is 20. So also when you have a situation like this, you will usually end up without any radicals in the end. Okay, on to the next example. So we have 7 plus 2 root x times 3 minus 5 root x. So look at this, we can see they're not conjugates, so we're not going to expect terms to cancel out. Instead, we'll just FOIL. So we've got 7 times 3 is 21. Then 7 times -5 would be -35. We've got the root x there. Then we have 2 root x times 3. So that would be plus 6 root x. And then we have 2 root x times -5 root x. So that would be 2 times -5 is -10. Root x times root x is root x squared. We'll go through and simplify this. These have the same root, so we can combine them. So we've got -35 plus 6, so that's -29 root x minus 10. We can take the square root of x squared, which will give us x. And we don't have any like terms, so this is as far as we can go with this example. Next, we'll talk about rationalizing the denominator. So in mathematics, radicals don't belong in our denominator, so we need to get rid of them, but in a way that doesn't change the value of a fraction. So to do that, what we'll do is multiply the numerator and denominator by the radical. So for example, if this first one, we have 1 over root 3, our radical in our denominator is root 3. So we'll multiply the top and bottom by root 3. In doing so, we're not changing the value because root 3 divided by root 3 is the same as multiplying by 1. So 1 times root 3 is root 3. Root 3 times root 3 is root 9. Root 3, we can't simplify. We can take the square root of 9. So we have root 3 over 3. So we no longer have a radical in our denominator. Next one, we have 2 over 3 root 5. Now we've got 3 root 5 in our denominator, but we only really have to multiply by the radical. So I'd multiply the top and bottom by root 5. So that gives me 2 root 5 over 3 root 25. So that gives me 2 root 5 over 3 times 5. So that's 2 root 5 over 15. Now, in some cases, you may have to reduce the terms after getting your radical out of your denominator. Now, this is what we do if we have just one term in our denominator. Now, we have a mixed radical here. It's considered one term because we don't have plus or minus in our denominator. If we have a plus or minus sum in our denominator, we're going to have multiple terms, in which case we can't use this method. If we have a binomial as a denominator, so 2 terms, we multiply the numerator and denominator by the conjugate of our denominator, creating a difference of squares. So we'll do this one first. So 1 over root 2 plus 3. The conjugate of root 2 plus 3 would be root 2 minus 3. So we multiply the top and bottom by that. So 1 times this isn't going to change much. It's going to be root 2 minus 3. For a denominator, we're going to have to FOIL it out. So we've got root 2 times root 2 is root 4. Root 2 times -3 is negative 3 root 2. Then we have 3 times root 2, so that's plus 3 root 2. And then we have 3 times negative 3. Now you'll notice the reason why we set up with conjugate is these middle terms cancel out. So that's going to get rid of those 2 roots. And any other roots we should be able to take the square root of, because, for example, we can take the square root of 4. So our numerator is going to stay the same. So root 2 minus 3, we can take the square root of 4, which is 2. And then we've got minus 9. We'll simplify this. That gives us root 2 minus 3 over 2 minus 9 is negative 7. Now, if we want to get the negative out of our denominator, we could, if we want, we could simply transfer negative to the numerator, and that'll just change the signs of what's on top. So a negative 3 becomes a positive 3. Root 2 becomes negative root 2 over 7. For me on a quiz or test, either of these would be fine for written, but you may have to swap from one form to the other in multiple choice or in workbook questions. Okay, next example, we've got 2 root 3 minus 4 root 6 over 3 root 2 plus 2 root 3. Now, once again, we're going to multiply the top and bottom by the conjugate of the denominator. So we're not worried about what the numerator is when we're doing this multiplication. So we had 3 root 2. We had plus 2 root 3, so it becomes minus 2 root 3. And then in this case, we're going to have to FOIL out both the numerator and the denominator. So FOILing this out, 2 root 3 times 3 root 2, so that'd be 6 root 6. Then 2 root 3 times negative 2 root 3, so 2 times 2 is negative 4. Root 9. And then I have negative 4 root 6 times 3 root 2, so negative 4 times 3 is negative 12. Root of 12. And then we have 4 root 6 times negative 2 root 3. So the negatives cancel out. So that's 4 times 2 is 8. Root of 18. And then that's all going to be over. 3 root 2 times 3 root 2 is 9 root 4. 3 root 2 times negative 2 root 3 gives us negative 6 root 6. 2 root 3 times 3 root 2 gives us 6 root 6. So those middle terms cancel out. Then we have 2 root 3 times negative 2 root 3, so that's negative 4 root of 9. Now we'll go through and simplify this a bit. So 6 root 6 minus 4 times 3, because the square root of 9 is 3. And then minus 12, we can simplify this. 12 is the same as 2 times 6. 6 is 2 times 3. So we have a 2 coming out. So 12 times 2 root 3. Same with the next one. We've got plus 8. 18 is the same as 2 times 9, which is 3 times 3. So we can have a 3 come out. So plus 8 times 3 root 2. All over 9 root 4, so that's 9 times 2 minus 4 times square root of 9 is 3. Okay, we'll go through and simplify this. So 6 root 6 minus 4 times 3 is 12. Then we've got negative 12 times 2, so minus 24 root of 3. And then we have 8 times 3, so that's plus 24 root of 2. We can't combine anything on the top because everything has different radicals. And we'll look at the bottom. So we've got 9 times 2 is 18. 4 times 3 is 12. So 18 minus 12 is 6. Now, if possible, we reduce to lower terms or do the division here. In this case, we can actually do that division. Everything up here is divisible by 6. So 6 root 6 divided by 6 is root 6. 12 divided by 6 is 2. 24 divided by 6 is 4. And 24 divided by 6 is also 4. So our final answer is root 6 minus 2 minus 4 root 3 plus 4 root 2. Now, practice for this section starts on page 121.